considering the nature of calculations inculcated in our syllabus, we are from medical and both non-medical backgrounds, so it's sometimes hard to understand what differentiation and integration's basic meaning is. See? So that is why I would try to give you the basic study of what exactly differentiation and integration mean and how do we use it in our physical calculations. Okay. So first of all, I'll start with differentiation, what exactly it means and what are the formulas which we would require throughout +1 and +2 physics. First of all, consider a graph. Y, have you heard of this thing? Y is a function of x. I'm trying to make this easiest possible for you guys to understand, especially for those students who are from medical background, alright, that is who have opted for medical. Y is a function of x means, suppose y is equal to 2x, y is equal to x square plus 2, y is equal to sine of x, y is equal to log of x, y is equal to tan x square upon 1 plus x. So anything which has a equation is a function. Now here everything, suppose I am representing y is equal to 2x, that means y is a dependent variable on x and x is an independent variable. What I mean is x can take any value and according to that the value of y will change. For example, if I put x is equal to 1 here, y will be 2. If I put x equal to 10, y will be 20. So value of y is depending on the value of x. Up to this point you are clear that there is a thing called function in which a value of one thing depends on the value of other. Now, every function has a graph. This was the main point that's why I started with the what is function. Every function can be plotted on a graph. For example, sine x. The graph of sine, if this side is y and this side is x, the graph of y is like this. This is sinusoidal wave. Y is equal to 2x. For y equal to 2x, I can plot a graph is y equal to 0, x equal to 0, y equal to 0, x equal to 1, y equal to 2, x equal to 2, y equal to 4. So this is how there will be a straight line. So for every function there is a graph. Alright. Now, this is what you want to know about function. Now, once graphs are plotted on suppose I plot a graph of a curve like this. Okay. I want to write the value of change from from this coordinate to this coordinate. What do I mean by change is, I am trying to find the slope of this line, this. Okay. So the coordinates, consider it to be x1, y1 and x2, y2. Okay. The change, that means how much this point has changed, or the slope of this line would be y2 minus y1 upon x2 minus x1. This is what we call as delta y upon delta x, change in y upon change in x. This is what slope is. How? This is how I figure out the value of slope. Slope is this much upon this much. This whole thing was y2, this much is y1, so y2 minus y1 is change in y coordinate and x2 minus x1 is change in x coordinate. Simple. If I want to find the change between this point and this point, so the graph would be the slope, this length would be much smaller and this would be the change. If I want the change between this and this line, the change will be further smaller in nature. So what if I want to find the slope at the last possible point? What will that give me? That will give me the tangent at that point actually, and that tangent, not just tangent, the slope of the tangent is what I'll get if I do change in y upon change in x. So if I put a limit that delta y over delta x, limit x tends to 0, that means I'm shortening this length up to the last possible value, then I'll get the slope of the tangent. This thing is actually called differentiation, which is dy upon dx. So in general, what does differentiation gives us? Differentiation gives us the slope of tangent at a point on the curve. This is what differentiation gives us. But the generalized meaning of differentiation, which will help you to understand the way we use differentiation formulas in our syllabus, is it is the smallest change in y upon smallest change in x. This is the smallest, the last possible change. So for a very small change in y upon very small change in x, this is what you have to remember for differentiation. dy is change in y, dx is change in x. For example, now I can write or I can speak this differential part in any language. For example, suppose dx be small change in distance in small time interval dt. So velocity will be given by dx upon dt. Suppose dv is small change in velocity in small time interval dt, then dv upon dt will give me the acceleration. What we are doing is, otherwise what was the formula for velocity? It was x upon t, and here it was v upon t, right? V or v minus u change in velocity. What we are doing is, we are finding the smallest possible value of change. That is why smallest possible value of change is in the differential format, that is dv and dt. So for a length, suppose this is complete length, the smallest possible length would be the differential part dl. That is what which will be used in calculating the smallest change. So this whole length is L, so the smallest part will be dl. So if I add a lot of dl all together, I'll get the complete length. This is what we do in integration. Integration is actually summing up all the differential part and making the whole body together. So if I integrate dl, I'll get the complete length again. If I have an area A and the smallest part is dA, and if I integrate dA, I'll get the complete area. For example, there is a circle and small length of this part is called dl. This is the smallest change or smallest part possible of the circumference. So I have a dl. If I integrate, I'll get the complete circumference or complete length. So dl would be 2 pi r. This is how we integrate, and after integrating we can also put on the limits. For example, I want the limits from this point to this point. So limit will be 0 to the half of the length is pi r, not 2 pi r, right? So how do we put limits? First of all, differentiation, the integration will give me the complete length, which is L, and then I'll put the value of limits, which is upper limit minus lower limit. That means instead of this thing, I'll be writing upper limit, minus instead of this thing, I'll be writing lower limits. This is how you apply integration. So in brief, differentiation, writing differential formats is writing the smallest possible value of that physical quantity, for example velocity. So the smallest change or smallest value would be dv, acceleration dA, force dF, any smaller values. And if I integrate it, I'll get the complete bigger picture, right? This is what required in basics of differentiation and integration.